Every password reset this Moodle site has sent so far has gone exactly nowhere. Mailpit caught them all, which was the whole point. But a site where nobody can actually recover their own account is not a site you hand to real students. Today, we give Moodle a real way out. Authenticated SMTP through a transactional relay, the 3 DNS records that decide whether your mail lands in the inbox or the spam folder, and then one message followed through every single layer until there is nothing left to assume. Welcome back to Open Education Operations. Let's get to work. Here is the route we are building. For this demonstration, I am using SMTP2Go as the outbound relay and Porkban as my domain registrar and DNS host. Porkban also forwards incoming mail for openeducationoperations.com, while SMTP2Go handles outgoing delivery only. We are not opening an SMTP port on the VPS, changing the domain's MX records, or turning the server into a mail receiver. The exact screens and field names will vary with other providers, but the workflow is broadly the same. Verify the sending domain, publish the DNS records generated by the mail provider, create a dedicated relay credential, connect Moodle, and test the complete delivery path. I have already created my relay account and turned on two-factor authentication. Now, the usual boundary. I am using a public demo server, not a live institutional system. The method transfers, but a real production site needs an approved maintenance window, current backups, and a tested rollback. Keep this in mind. Before we change the route, let's confirm where Moodle sends email today and whether this server can reach the relay securely. This read-only loop asks Moodle for the non-secret settings that define the current mail route. The loop changes only the setting name. sudo-u www-data runs Moodle CLI as the web service account. And cfg.php-name reads the stored value without modifying it. Moodle currently submits to Mailpit on the loopback address. Security and username are empty. SMTP authentication type =login is stored, but it has no effect while the user and password are empty. The value email from via =1 mean Moodle's via information is set to always. Now I will test the secure network path from this VPS to SMTP2Go. This command checks 4 things at once: DNS resolution, outbound TCP on port 587, the STARTTLS upgrade, and certificate validation. Swap in your own relay's submission hostname and the rest of the command is unchanged. Here is what the command is doing. -start-tls SMTP begins as SMTP, then upgrades the connection to TLS. -connect selects SMTP2Go on port 587. -server name sends the TLS server name used for certificate selection. And -brief keeps the output readable. This proves the secure network path works from this server. It says nothing about credentials or delivery. Those come later from the application itself. If this one fails, stop here. Some hosting providers block outbound mail ports by default, and no amount of Moodle configuration will fix a blocked port. You have 3 ways out of that. Ask your host to open the port, try an alternate submission port if your relay offers one, or move to a host that allows outbound mail. With the current route documented and the TLS path working, we can prepare the outbound relay. I will start in SMTP2Go under Sending, Verified Senders, and Sender Domains. Other relay services might use labels such as Sending Domains, Authenticated Domains, or Verified Senders. But the purpose is the same. Prove that the provider is allowed to send for our domain. The relay needs permission to send mail using openeduops.com at the domain level. so Moodle can use addresses under this domain without approving them one by one. So I will choose Add Sender Domain and enter openeduops.com. Then I will continue with manual DNS setup so we can see and publish the records ourselves. SMTP2Go has generated 3 CNAME records for this account. These names are specific to my domain and SMTP2Go account. If you use another provider, publish the exact records shown in your own dashboard. Each one has a separate job. The EM record gives the relay a custom return path under our own domain. That address collects bounces and it supplies the identity that recipients check SPF against. The underscore domain key record publishes the route to the relay's DKIM public key. The relay keeps the private key and signs every message it sends on our behalf. The link record creates a branded tracking hostname. It belongs to the sender domain setup. Open and click tracking will stay switched off for Moodle's SMTP user regardless. I will keep this page available while we work in DNS, because verification cannot succeed until these exact names resolve publicly. Next, I will open a new tab and move to Send-in SMTP users. Moodle should have its own relay identity that keeps this credential separate from the main provider account and makes it much easier to rotate or revoke later. I will choose Add SMTP User and give it a name. For this demonstration server, I am applying these restrictions. The rate limit is deliberately modest for this demonstration service and I will put it as 100 messages per hour. Open and click tracking are unnecessary for Moodle's transactional mail. And a marketing and subscribe footer does not belong in password receipt or form messages. SMTP2Go now generates a password for this user. I will save it securely in my password manager, then activate the user. Once that's done, we can continue. The dedicated user is ready. Next comes the public DNS work that gives the sender domain a verifiable identity. Next, let's jump to porkban and start by reviewing the existing DNS table so we do not disturb records that already have a job. The Moodle A record keeps the site reachable. The root alias and wildcard CNAME handle the current domain behavior. The MX records and root SPF policy support incoming mail forwarding. And the Acme challenge records support certificate automation. Every one of these records stay exactly where it is. We are adding 4 new records without changing any existing ones. Now let's add the 3 records using porkban's DNS editor. You can do the same through any DNS host. The labels may appear as host, name or record, and answer, value, or target. What matters is copying the record type, name, and target exactly as the mail provider generated them. The first record delegates SMTP2Go's custom return path. Here are the values I am entering for my domain. Porkban automatically appends openeduops.com to the host field. So the EM value becomes em716.596.openeduops.com. Some DNS panels expect the complete hostname instead. So this is one place where the interface might differ. I am using a 10-minute TTL while publishing and testing. Once the setup is stable, the longer TTL recommended by the provider can be applied during later maintenance. After saving, I will confirm that the record appears once. A duplicate at the same name would make the DNS state ambiguous. The second record connects SMTP2Go's DKIM selector to its public key service. These are the values I am entering. The selector is the value starting by S. Receivers use that selector together with the sign-in domain to find the public key and check the message signature. After saving it, double-check the record against the values generated by SMTP2Go. DKIM can fail silently when those values are wrong. The third SMTP2Go record creates the branded tracking hostname. For my domain, these are the values I am using. Publishing this name does not turn tracking on. The SMTP user settings still control whether open and click tracking are applied, and both remain off. Now let's handle DMARC. SPF and DKIM authenticate message identities. DMARC connects those results to the domain in the visible from address and provides a policy and reporting channel. For this demonstration, I am using Postmark's DMARC monitoring service. First, I will enter openeduops.com and the email address where I want Postmark to send the monitoring digest. Postmark now generates a complete DMARC text record value for this domain, including a dedicated address for receiving aggregate reports. I will copy the complete value exactly as generated. Now I will return to porkban and create the DNS record. Before adding it, make sure your domain does not already have a DMARC record. A domain should publish only one DMARC text record at _DMARC. If one already exists, review and update it carefully instead of creating a second record. For the record type, I will select text record. In the host field, I will enter _DMARC. In the answer field, I will pass the complete value generated by Postmark. I will leave the TTL at 600 seconds and save the record. The generated value follows this structure. V equal DMARC1 identifies this as a DMARC record. P equal none places the domain in monitoring mode. Receiving servers can evaluate DMARC and send reports. But this policy does not ask them to quarantine or reject failing messages. The reporting address provides the Postmark-generated address where participating receivers can send aggregate DMARC reports. SP equal none applies the same monitoring policy to subdomains, while ASPF equal R enables relaxed SPF alignment. The generated record also contains PCT equal 100. This is a legacy DMARC tag retained in Postmark's generated value. It does not change the monitoring-only behavior of P equal none. Now I will return to Postmark and verify. Postmark finds the public text record and displays you are all set. Great. This confirms that the DMARC record has been published correctly and is visible through public DNS. It does not mean that DMARC reports have already arrived. Those reports will appear later, as participating mail providers process messages from this domain. Now our preferred part. Let's confirm that all 4 new DNS names appear once. Let's go to the terminal. Seeing the records in a DNS dashboard does not yet prove that public resolvers can find them. After allowing time for publication, I will query the 3 CNAMEs from my workstation. Each command requests one public CNAME. Together, they confirm that the return path, DKIM, and tracking names now resolve to SMTP2Go. Before these exact records existed, my porkban wildcard could answer with something like uixie.porkban.com, for example. In this setup, seeing that fallback now would mean that required record is still missing or has not reached the resolver. Okay, now the DMARC. Let's check DMARC separately by querying the txt record at _DMARC. The result proves that a DMARC policy is publicly available. It does not prove a message passes DMARC. That evidence comes from a real recipient later. We will test that. With the records visible publicly, I will return to SMTP2Go's sender domain page and select Verify. Great! This confirms that SMTP2Go can find the return path, DKIM, and tracking records it's issued. We changed 4 exact DNS names, but we did not intend to touch incoming mail forwarding or the root SPF policy. I am going to recheck both before moving on. First, I will read the Emacs records again. In my setup, the Emacs results confirms that Porkban's 2 forwarding servers and their priorities are unchanged. If your domain uses another incoming mail provider, the goal is the same. Its original Emacs records should remain intact. Then I will reread the root text records. The text result confirms that my existing Porkban SPF policy is unchanged also, with no duplicate SPF record and no SMTP to go include added at the root. The exact SPF value will be different for domains using another mail service, of course. You can send a control test message to an address on your domain and confirm that it still reaches the destination. If the message arrives successfully, it confirms that the outgoing mail setup has not disrupted incoming mail forwarding. Now, the next step moves Moodle from local capture to the new relay. Let's do it. Now, we will visit our old friend Moodle. From Site Administration, I will open Server. Then in the Email category, I will click on Outgoing Mail Configuration. Moodle is still pointed at the loopback address at the port 1025, which is the local Mailpit listener. We will replace that route with authenticated submission over STARTTLS. These are the values I am using for this SMTP to go setup. With another relay, the host, port, security mode, authentication method, username, and sender domain should come from that provider's documentation or dashboard. Port 587 is SMTP submission. Moodle's TLS choice uses STARTTLS, so the connection begins as SMTP and upgrades to an encrypted channel before authentication. Login is the authentication method configured for this SMTP2Go user. The session limit stays at 1, which is a conservative value for this small demonstration site. The no-reply address uses the verified sender domain. That lets recipient systems evaluate the visible from domain against SMTP2Go's SPF and DKIM identities. Now, allowed email domains. This field gets misread consistently. It is not a list of domains Moodle is permitted to send to. It controls when Moodle may use a user's own address in the from header. Leaving it empty means Moodle consistently uses the no-reply identity we just configured. While its via information still tells the recipient which user the message is really about. Leave Moodle's DKIM selector empty as well. The relay signs the message on the way out, so configuring Moodle to sign it too would create a second key to manage for no benefit. Don't forget to add the SMTP username and the SMTP password in their respective fields. Then save the configuration. This green banner means Moodle accepted the configuration, but it does not prove that the values were stored exactly as intended or that an external recipient can receive a message. So I will return to my SSH session and use the same read-only loop to confirm the settings. The loop confirms the relay host, STARTTLS mode, authentication method, username, sender address, domain restriction, and via setting exactly as saved. For the password, I only need a safe yes or no status, not the credential itself. This confirms that a credential is present. We have now checked the route, encryption mode, authentication mode, username, sender address, and presence of a password. Configuration is only the middle of the job. The next tests follow a message across every layer instead of treating Moodle's safe confirmation as the finish line. To test the route, I will return to Moodle's email section and click on Outgoing Mail Configuration. Now I will check for the test section. I will enter my external mailbox and choose Send a Test Message. Moodle successfully submitted the message. that confirms the application could connect, negotiate TLS, authenticate, and hand the message to the relay. But it does not yet prove that SMTP2Go delivered or that recipient accepted. Next, I will return to the SMTP2Go dashboard and select Reports, then Activity. And I will locate the event with the correct subject, which is in this case OpenEDU Ops Moodle test message. Delivered. This means the receiving mail server accepted the message from SMTP2Go, but it does not promise inbox placement. The recipient can still sort the message into another folder. Which brings us to the part your users actually experience. Did the message land in my inbox? I am using a Gmail inbox for this test. The message has arrived in the inbox. So we now have evidence from Moodle, SMTP2Go, the receiving server, and the recipient mailbox. Another mailbox provider may place it elsewhere or expose the message details through a different menu. One layer remains: authentication and alignment. In Gmail, I will open the message menu and choose Show Original. Other mailbox services may use labels such as message source, row headers, or view headers. But we are looking for the same authentication evidence. At the top, Gmail reports that SPF, DKIM, and DMARC all passed. Those results are useful, but let's look at the identities behind them. I will use Ctrl F to search and start with return path. The return path is the envelope address used to handle bounces. For this message, its domain is the following. This is the identity SPF checks, because it is a subdomain of openeduops.com. It aligns with our visible from domain and the relaxed SPF alignment. Next, I will search for D equal. Inside a DKIM signature, D equal identifies the domain that signed the message. You might find more than one DKIM signature. For example, SMTP2Go can also add a provider signature using smtpservice.net. That additional signature is normal. The signature that aligns with our visible from domain is D equal openeduops.com. This is an exact match with the domain our recipients see. Now I will search for S equal. Inside the same DKIM signature, S equal is the selector. It tells the receiving server which public key record it should retrieve from DNS to verify the signature. In this message, the selector is the following. Together, the selector and sign-in domain point to the DNS record we published earlier. Finally, I will search for header.from. This shows the domain in the visible from address. Header.from equal openeduops.com. This is the domain DMARC protects. DMARC compares it with the authenticated SPF and DKIM identities. It needs at least one passing identity to align. For this message, SPF aligns in relaxed mode, and DKIM aligns exactly. That explains why DMARC reports a pass. I am showing only the authentication summary on the domain values we need. The rest of the raw message contains recipient-specific and message-specific information that does not help with this check. This controlled message passed SPF, DKIM, and DMARC with the expected alignment. It proves that this route worked for this message and this recipient. It does not guarantee that every future message will reach every inbox. And trust me, anyone who tells you otherwise is selling something. Now, when we first configured Mailpit for local testing, we verified Moodle email in 3 ways. Moodle's built-in outgoing mail test, a user password receipt, and a forum notification. Now that the site is using a real SMTP relay, we will repeat the same checks. The built-in test is already complete, so next we will trigger a password receipt for our dedicated test user. I will open Moodle in a private browser window and choose Forget Password. Now I will use the test user's email address. Now let's jump to the test user's mailbox. I am using a redirection to use only one email, so all emails will go to the same mailbox. Now let's open the email and check for the domain in the receipt link. Great, as expected, moodle.openeduops.com. That confirms Moodle used the correct public site address when constructing the message. The password receipt path is working. Next, we will test a queued form notification, which adds Moodle cron to the route. I have created a course, enrolled the test user, and added a forum with forced subscription enabled. Next, I will create a discussion and enter some simple text content in the subject and message fields. And for this controlled test, I will expand the advanced options and then check the send form post notification with no editing time delay. This bypasses Moodle's usual 30-minute editing window, allowing the notification email to be sent immediately. With the subject, message, and notification option in place, I will now choose Post to Forum. Right after posting the discussion, I will return to my SSH session and run Moodle's cron command to process the notification immediately. This command starts Moodle CLI cron as the web service account. Cron might take a little while to finish, so I will use a touch of editing magic and spare you the wait. After cron finishes, I will check the mailbox and the corresponding event in SMTP2Go's activity log. The forum notification has arrived. Now let's check in with our SMTP2Go friend. It shows the message as delivered. This confirms the scheduled notification workflow, not just Moodle's direct diagnostic test. And with that, we have completed the prove it part. Now, as always, let's check the firewall and confirm that nothing has changed. The relay uses an outbound connection to port 587. It does not require an inbound SMTP rule. So let's list the active UFW rules with stable numbers. Everything looks as expected, with no new firewall rules introduced. The firewall tells us what traffic is allowed. The socket list tells us what services are actually listening. Here is how I am reading the results by address and port. Nothing listens on 25.465 or 587. Mailpit remains on loopback on the ports 1025 and port 8025. MariaDB remains on loopback on port 3306. SSH and Apache are the intended public listeners. SMTP2Go did not add a daemon to this server. Moodle opens an outbound client connection when it needs to submit mail. The new route has now passed direct delivery, authentication, a password receipt, a cron-driven form notification, and the negative network check. Mailpit has served its purpose, so we can retire it finally. Moodle has delivered through SMTP2Go where Mailpit is still available. I will now stop it and prevent it from starting at boot. This gives us a short rollback window where we prove that Moodle no longer depends on the old local route. In this command, --now stops the service immediately, while disable prevents it from starting automatically after a reboot. This deactivates Mailpit, but it does not remove it from the server. A very important note here. Once the new mail route has remained stable, unused software should be removed from a production system. The companion guide includes the exact commands to delete Mailpit and its remaining components safely. Now I will confirm both the running state and the boot configuration with one read-only query. Inactive and dead confirm there is no running Mailpit process. Disabled confirms it will not return automatically after reboot. I will also check Mailpit's former ports directly. Great! With no machine listener, the fallback message confirms that Mailpit ports are closed. Our Moodle is now sending real transactional email through an authenticated relay. The inbound route through the registrar is untouched. The sender domain is verified through exact DNS records. DMARC is published in monitoring mode. and we verified each layer instead of assuming the route worked. Together, the checks form one evidence chain that leaves this server with one clear mail rule. Moodle submits outbound messages to the relay, and the domain's existing provider keeps handling anything coming in. If you are building a Moodle stack you can actually hand to other people, subscribe to Open Education Operations. I will see you in the next one.